When you lie in bed at the end of the day, ready to drift off to sleep, have you ever felt that the earth beneath our feet is utterly solid and still? This tranquility is a wonderful illusion. In reality, we are aboard a massive spaceship called Earth, racing through the cosmos at astonishing speeds. We don't sense the motion because we ourselves, along with everything around us, including the air we breathe, are moving at the same speed and direction as the Earth. It's like being on a large ship sailing smoothly across a windless sea. Close all the windows, and you won't feel the ship moving. In physics, this principle is called relative motion or inertia. The spacecraft we inhabit, Earth, operates in the near vacuum of space. There are no trees or buildings along the road to serve as reference points and tell us intuitively how fast we're moving. The only reference points revealing this voyage are the sun, moon, and stars in the sky. Yet they are so distant that their apparent motion over short periods seems slow and solemn. Earth's gravitational pull is powerful and constant, holding us and the atmosphere firmly anchored to the spacecraft's surface, preventing us from being flung into space by the planet's rotation. This gravitational force counteracts centrifugal force, allowing us to stand, walk, and sleep securely. Imagine if Earth suddenly ceased its rotation. It would be an unimaginable catastrophe. But fortunately, the laws of the universe are so harmonious. They make our voyage both swift and smooth. So tonight, when you close your eyes, know that you lie aboard a meticulously engineered spacecraft, carrying you through the stars in eternal silence. This awareness may bring an unprecedented sense of tranquility and security. Now let us explore the invisible engine driving this spacecraft's day-night cycle, Earth's rotation. Our planet continuously spins west to east around an imaginary axis connecting its north and south poles. This seemingly simple motion dictates the most fundamental rhythm of our existence. Earth rotates at a staggering speed of approximately 466 meters per second. This equates to 1,670 kilometers per hour, a speed far exceeding the cruising speed of commercial airliners, and surpassing the limits of most fighter jets. Imagine lying atop a natural gyroscope spinning at supersonic speeds, a gyroscope that has maintained this stable rotation for over 4.6 billion years. It is this unceasing rotation that allows each face of Earth to periodically face or turn away from the sun. When your home faces the sun, sunlight floods the land. This is day. When it turns into the shadow away from the sun, night falls. This alternation of light and dark constitutes what we call a day. This cycle lasts approximately 24 hours. Earth's rotational axis is not perpendicular to its orbital plane. Instead, it tilts at an angle of about 23.5 degrees. This tilt is crucial. We'll explore it in detail later. Combined with its orbit, this tilt shapes the seasons. But even on its own, Earth's rotation influences its physical form. Constant spinning causes the equatorial region to bulge slightly, while the poles appear relatively flattened. This makes Earth not a perfect sphere, but an oblate spheroid. The circumference measured at the equator is about 67 kilometers longer than that measured along the poles. Earth's rotational speed is not constant. Tidal friction induced by the moon's gravitational pull and geological events like major earthquakes are gradually slowing Earth's rotation. This means the length of a day is subtly increasing by about 1.7 milliseconds per century. This change is so small it remains entirely imperceptible in our daily lives. Yet it reveals the intricate and complex interplay between celestial bodies in the cosmos. So whenever you witness sunrise or sunset and feel the natural conclusion of a day, you should recognize it as proof of the steady operation of Earth's invisible engine, providing one of the universe's most reliable rhythms. May you find the rhythm of peaceful sleep, It faithfully orbits the star known as the Sun year after year. This journey is called revolution. Earth's orbital speed reaches 29.79 kilometers per second. This figure means we travel over 2.57 million kilometers through space every single day. Each year, Earth covers a total distance of nearly 940 million kilometers. This distance is sufficient to take you from Earth to the Sun and back, and then back again more than 3 times. We can visualize Earth's orbit as an ellipse that closely approximates a perfect circle. The Sun occupies one of the 2 foci of this ellipse. Thus, throughout Earth's annual journey, its distance from the Sun undergoes subtle variations. When Earth reaches its closest point to the Sun, we call this the perihelion. The distance at this point is approximately 147 million kilometers. This typically occurs in early January. Conversely, when Earth reaches its farthest point from the Sun, we call this the aphelion. At this point, the distance is approximately 152 million kilometers. This typically occurs in early July. You might wonder why January, the coldest month in the northern hemisphere, coincides with Earth's closest approach to the Sun. This is because the primary factor determining seasonal changes is not the slight variation in Earth-Sun distance, but rather the tilt of Earth's rotational axis. Earth's rotational axis does not stand vertically within the plane of its orbit, but maintains a constant tilt of approximately 23.5 degrees. As Earth orbits the Sun, this tilt causes the region directly illuminated by the Sun to shift between the Tropic of Cancer and the Tropic of Capricorn. When the Sun shines directly on the northern hemisphere, it concentrates solar energy more intensely there. Land and oceans absorb greater heat per unit area, thus ushering in summer in the northern hemisphere. Daylight hours also become relatively longer. Meanwhile, the southern hemisphere experiences oblique sunlight, with dispersed energy reception, thus entering winter. Half a year later, as Earth traverses the opposite side of its orbit, sunlight shifts to directly illuminate the southern hemisphere, causing seasonal reversal. The southern hemisphere welcomes summer while the northern hemisphere enters winter. During spring and autumn, sunlight roughly illuminates the equatorial region directly, resulting in nearly equal day and night lengths worldwide. The climate remains mild. Thus, the cycle of seasons is not determined by our distance from the Sun, but by the Earth's constant tilt as it orbits. This tilt allows the Sun's energy to sweep across the planet like a warm, steady hand, gently caressing different latitudes, to create diverse climate zones and vibrant natural rhythms. This perpetual revolution provides the astronomical foundation for our calendar and shapes the cyclical rhythms of all living things. Earth's position in the solar system is nothing short of perfect. It lies precisely within a narrow zone known as the habitable zone or Goldilocks zone. This region is neither too close nor too far from the Sun, allowing Earth to receive just the right amount of solar energy to sustain liquid water stably on its surface. Were Earth's orbit closer to the Sun, like Venus, excessive solar radiation would cause temperatures to soar, triggering an uncontrollable greenhouse effect, evaporating oceans entirely, and turning the surface into a furnace-like inferno. Conversely, if Earth's orbit were farther from the Sun, like Mars, insufficient solar energy would render the planet too frigid for water to exist except in permanently frozen states. The atmosphere would also become too thin to sustain complex life. Earth's orbital path itself is remarkably stable. It is nearly circular. This ensures that throughout its entire revolution, the total solar radiation received by Earth remains within a relatively constant range, avoiding extreme climate fluctuations. If Earth's orbit were an extremely elongated ellipse, at aphelion, Earth would plunge into prolonged ice ages. while at perihelion, it might face global scorching heat. Such drastic temperature fluctuations would pose immense challenges to life's evolution and survival. Earth possesses a moderately sized metallic core, whose continuous rotation generates a powerful global magnetic field. This field forms an invisible protective shield. Known as the magnetosphere, it deflects high-energy charged particle streams from the sun, the solar wind, preventing the gradual stripping away of Earth's atmosphere, while shielding surface life from harmful radiation. Comparing Earth to Mars reveals the critical importance of this magnetic field. Mars, however, lost its magnetic field as its core cooled. Its atmosphere was nearly entirely stripped away by the relentless bombardment of solar wind, leaving it as the dry, frigid wasteland we see today. Earth's moderate mass and size endow it with sufficient gravity to retain an atmosphere primarily composed of nitrogen and oxygen. This atmosphere not only provides the air we breathe, but also acts like a blanket trapping heat to maintain a pleasant global average temperature of around 15 degrees Celsius. Simultaneously, the atmosphere serves as the first line of defense against asteroid impacts. Countless meteors burn up in the atmosphere due to friction, as they streak across the sky as beautiful shooting stars. The exquisite convergence of these conditions, a perfectly balanced orbit, a stable atmosphere, liquid oceans, a protective magnetic field. Together, these elements transform Earth, our cosmic spacecraft, into a unique oasis of life within the known universe. What we possess is not a random habitat, but a precious home, meticulously designed and shaped by eons of evolution. Recognizing this allows us, when gazing at the stars, to cherish all the more the fragile blue world beneath our feet. The Earth spacecraft navigates the perilous cosmos safely, thanks to two vital life support systems, the atmosphere and the global magnetic field. Imagine them as the spacecraft's pressurized cabin and deflection force field, jointly shielding us from outer space threats. Our atmosphere is a protective shell composed of a mixture of gases, tightly enveloping the Earth's surface. Its primary components are nitrogen and oxygen, along with argon, carbon dioxide, and other trace gases. This atmosphere is not uniformly distributed, but divided into distinct layers based on altitude and temperature. Closest to our daily lives is the troposphere, where all weather phenomena occur. It functions like the air conditioning system constantly circulating within the spacecraft. Above lies the stratosphere, where the vital ozone layer resides. This layer absorbs the majority of harmful ultraviolet radiation from solar radiation, acting like a natural sunscreen, protecting life on Earth's surface from radiation damage. Further up are the mesosphere, thermosphere, and exosphere, together forming the transition zone between Earth and interstellar space. The atmosphere first provides the oxygen we need to breathe. This is the life support gas built into the spacecraft. Simultaneously, it acts like a giant blanket, trapping some of the heat reflected back from the Earth's surface through the greenhouse effect. This maintains the global average temperature within a range suitable for liquid water, avoiding the extreme day-night temperature differences seen on Mars. The atmosphere also serves as a faithful guardian. Most small celestial bodies entering the atmosphere from space experience intense friction with air molecules and burn up. This is what we see as shooting stars at night. Most meteoroids burn up completely before reaching the ground, preventing frequent impact events. However, the atmosphere alone is insufficient to counter all space threats. This is where Earth's magnetic field comes into play. Earth's magnetic field originates from the continuous flow and electrical conductivity of molten iron-nickel material within the outer core. This process functions like a giant self-sustaining generator, generating magnetic field lines that encircle the entire planet. These field lines extend from the geographic North Pole into deep space, then return to the geographic South Pole, forming a protective region known as the magnetosphere. The Sun continuously emits streams of high-speed charged particles, the solar wind. As the solar wind approaches Earth, the magnetosphere effectively deflects and blocks it, causing most high-energy particles to bypass Earth along the magnetic field lines. Without the magnetosphere's protection, the relentless solar wind would directly bombard Earth's atmosphere, just as it did to Mars, gradually stripping away the atmosphere and dispersing it into space, leaving Earth dry and barren. During periods of intense solar activity, a small fraction of charged particles are captured and guided along magnetic field lines toward the poles, where they collide with atoms in the upper atmosphere, creating the dazzling, dreamlike aurora. Auroras are not merely a spectacle in the night sky, but tangible proof of the magnetosphere at work. When exceptionally powerful solar storms strike, they can compress our magnetosphere and trigger intense geomagnetic storms, which may disrupt the power grids and satellite communications upon which our modern technological society relies. Yet this serves as a stark reminder of how vital our protective shields are. It is the combined guardianship of our atmosphere and magnetic field that maintains a stable, tempered environment within Earth's spaceship, allowing life to thrive for billions of years. Tonight, as you drift peacefully to sleep, imagine these two invisible shields faithfully at work. They filter out harmful radiation, ward off the assault of interstellar debris, and preserve the air we depend on for survival. Under this dual protection, you can confidently surrender yourself to slumber, entering tranquil dreams amidst the safe voyage of Spaceship Earth. When we comprehend Earth's own motion, a grander picture unfolds before us. Earth does not drift alone through the cosmos. It is a member of the solar system, an interstellar fleet, and the entire fleet races alongside its pilot, the Sun. This star, which holds 99.86% of the solar system's total mass, exerts a powerful gravitational pull due to its immense mass. This gravitational force acts like an invisible cosmic tether, firmly anchoring the 8 planets and their moons, countless asteroids, dwarf planets, and distant comets, all celestial bodies, compelled to orbit around it. The motion of the entire solar system can be viewed as the superposition of two components. First, the individual orbits of each fleet member around the Sun. Second, the collective movement of the entire fleet through the Milky Way galaxy. The Sun's gravitational influence extends to vast distances, reaching as far as the Oort cloud over a light-year away, where trillions of icy comet nuclei remain under the Sun's faint gravitational grasp. This implies the solar system spans approximately 2 light-years in diameter, while Earth resides a mere 8 light-minutes from the Sun. Imagine the Sun as a colossal cosmic sailing vessel, with Earth and the other planets as smaller escort vessels circling around it, forming a well-ordered convoy. This convoy is not stationary, but, led by the Sun, orbits around the center of the Milky Way at a staggering speed of 220 kilometers per second, in a journey spanning hundreds of millions of years. This speed is over 7 times faster than Earth's orbital velocity. The reason we remain securely within this pilot ship without noticing is that the entire fleet, including ourselves, exists within the same inertial reference frame. We all share the same velocity and direction. It's like being on a high-speed train moving at a constant pace. You don't constantly feel the train's speed. Only when you gaze out the window at the starry sky can you indirectly calculate how fast we're moving through space, indirectly infer how swiftly we traverse the cosmos. The Sun, our navigator, rotates slowly on its axis. Yet, as a gas giant, its rotational speed varies across different latitudes. This intricate internal motion, coupled with its immense gravity, shapes the entire solar system's dynamic structure. It is this eternal gravitational pull from our star that has kept our Earthship orbiting stably for billions of years. It provides a lasting and reliable source of energy and a gravitational anchor for the birth and evolution of life. The Sun leads our entire solar system fleet on a journey through the Milky Way measured on a colossal timescale, known as a galactic year. This unit of time refers to the duration required for the solar system to complete one full revolution around the galactic center, based on astronomers' observations and calculations. This cycle spans approximately 250 million years. Our solar system was born roughly 4.6 billion years ago, counting from when it began orbiting the galactic center. It has now completed about 18 full revolutions. Or, in other words, we have experienced 18 galactic years. This is a thought-provoking concept, meaning Earth's age roughly corresponds to 18 galactic years. As Earth gradually cooled and formed primordial oceans during its first galactic year, the solar system itself was still in its infancy. We can attempt to map Earth's geological eras onto galactic years. At the start of the previous galactic year, Earth was in the late Permian period. The supercontinent Pangaea had just formed, followed by the most severe mass extinction event in Earth's history. The Cretaceous-Paleogene extinction event, which wiped out the dinosaurs 66 million years ago, occurred in the latter half of the previous galactic year. If we compress Earth's 4.6 billion year history into a single 24-hour day, each galactic year would correspond to roughly 53 minutes of real time. Human civilization, with its recorded history, occupies merely the final few seconds of this vast day. This grand temporal cycle reminds us that the rhythms of the cosmos are far slower and more enduring than our daily perceptions suggest. The solar system's orbit within the Milky Way is not a perfect circle, but rather a slightly elliptical shape. This means that over a 250 million year cycle, our distance from the galactic center fluctuates between 25,000 and 28,000 light-years. Currently, we are positioned closer to the galactic center, at approximately 26,000 light-years. Though this distance shift occurs gradually, it may exert subtle influences on Earth's long-term climate and environment. When the solar system traverses denser regions of the Milky Way, such as spiral arms, the probability of minor celestial impacts on Earth may increase. This is because dense interstellar matter can disturb the Oort cloud, sending more comets into the inner solar system. Some theories suggest that Earth's periodic mass extinction events throughout history may be linked to the solar system's roughly 60 million year cycle of traversing galactic spiral arms. The concept of the galactic year reminds us that we live not only within the cycles of day and night, seasons and years, but also within a grand, star-driven rhythm spanning hundreds of millions of years. This cycle has shaped Earth's deep history and may subtly influence the long-term evolution of life itself. Tonight, as you gaze upon the stars and contemplate our journey with the Sun through this 18th galactic cycle, you may sense an eternal rhythm transcending individual existence. Within this slow, steadfast cosmic pulse, our troubles seem insignificant, our minds grow tranquil, and peaceful sleep comes more easily. The path our solar system traces through the Milky Way is not a flat straight line, but rather an elegantly undulating waveform. The Milky Way itself is a disc-shaped structure with several spiral arms. This vast disk is called the galactic disk. The solar system does not perpetually orbit precisely within the central plane of this disk. This central plane is known as the galactic plane. Instead, our Sun periodically crosses the galactic plane and is then pulled back by gravitational forces, forming a repetitive pattern of undulating motion. Through observation and calculation, astronomers have determined that the solar system completes one full cycle of this up and down crossing approximately every 32 to 33 million years. It is like a giant ship sailing on calm seas that, besides moving forward, also gently rises and falls with the soft waves. The force driving this undulating motion of the Sun primarily stems from the mass distribution within the galactic disk itself. The gravitational pull exerted by stars and vast amounts of dark matter within the disk combines to act upon the solar system like an invisible force field guiding our course. When the Sun lies north of the galactic plane, the gravitational pull of the galactic disk material tugs it southward. After crossing the galactic plane into the southern region, gravity reverses direction, pulling it back northward. This periodic up and down motion causes our relative position to the densely populated central region of the Milky Way to constantly shift. When the solar system crosses the galactic plane, it enters regions where interstellar matter is relatively dense. These areas are filled with more gas and dust clouds. Although these materials remain extremely sparse in space, their subtle density variations can significantly disturb the gravitational field of the Oort cloud at the outer edge of the solar system. This disturbance is akin to gently stirring a pool filled with small balls using a long rod. It may alter the stable orbits of some of these icy bodies, awakening them from their slumber and propelling them toward the inner solar system. Some may become the comets we observe, while others could embark on dangerous trajectories that intersect with the inner planets. This periodic crossing carries the potential for long-term rhythmic impacts on Earth's environment. Though we reside within the inner solar system and cannot directly perceive these slow undulations, they may have etched periodic imprints across Earth's lengthy history. The next time you witness a meteor streaking across the night sky, consider that it might originate from a distant galactic plane crossing, a tiny ripple in this grand cosmic dance. The solar system's overall motion through the Milky Way is not without trace. Like cosmic tidal forces, it has left profound imprints on Earth's long history of life. Among the most compelling evidence may be linked to Earth's periodic mass extinction events. Through studying Earth's rock layers and fossil records, paleontologists and geologists have discovered that over the past 500 million years, life on Earth has endured at least 5 major extinction events. These events wiped out most species of their time, clearing space for subsequent life to evolve and rise. Some scientists have noted that these mass extinction events appear to follow a roughly cyclical pattern, spanning approximately 26 to 30 million years. This time frame bears a thought-provoking similarity to the period of the solar system's passage through the galactic plane and its vertical oscillation cycle. A prevailing hypothesis suggests that as the solar system periodically traverses the galactic plane, the higher density of interstellar matter there exerts gravitational effects that disturb the distant Oort cloud. The Oort cloud is a spherical nebula at the solar system's edge, composed of trillions of icy bodies. When the orbits of these icy bodies are disrupted, some enter the inner solar system as long-period comets, significantly increasing the probability of comet impacts on Earth and its surroundings. An impact by a sufficiently large comet or asteroid would trigger global catastrophic consequences. The violent collision would directly ignite worldwide wildfires and generate super tsunamis. Massive amounts of dust and aerosols ejected into the stratosphere would block sunlight, causing global temperatures to plummet into an impact winter. Interrupted photosynthesis in plants would collapse food chains, ultimately leading to the disintegration of global ecosystems, beyond theories suggesting increased impact probability. Hypotheses propose that when the solar system traverses denser regions like galactic spiral arms, cosmic ray flux may intensify, potentially exerting complex effects on Earth's climate and biosphere. Though these theories linking astronomical cycles to Earth's biological events remain in the phase of scientific exploration and evidence gathering, they offer an extraordinarily grand perspective, reminding us that life's evolution on Earth does not unfold within a completely isolated, closed system. The fate of our Earthship is inextricably linked to the solar system's trajectory through the Milky Way. The solar system navigates the cosmic ocean like a fleet of starships. The gravitational ripples it stirs and the density fluctuations it encounters function like interstellar tides that ultimately affect every vessel in the fleet, including our Earth. Recognizing this, we can view our place in the cosmos with greater humility and reverence. We are both inhabitants of Earth and citizens of the Milky Way. Our history of existence is inextricably linked to the dynamics of the entire galaxy. Tonight, as you close your eyes, imagine us riding the waves of the Milky Way's gravitational sea, aboard the solar system's mothership, experiencing tides rising and falling over millions of years. This awareness may help you release the anxieties of the day and find inner peace and tranquility within the vast cosmic rhythm. When we speak of the solar system, our imagination often remains confined to those 8 familiar planets, perhaps extending to the asteroid belt between Mars and Jupiter's orbits. Yet the true expanse of our solar system is vastly greater. In the cold, dark depths far from the sun's blazing light lie 2 immense, frozen vaults of treasure, the Kuiper Belt and the Oort Cloud. These regions are the birthplace of most comets, outlining the ultimate boundary of the sun's gravitational influence. They also guard the primordial secrets of the solar system's formation. First, let's explore the relatively closer Kuiper Belt. Located beyond Neptune's orbit, the Kuiper Belt spans a vast region roughly extending from 30 to 50 astronomical units from the Sun. 1 astronomical unit is the average distance between Earth and the Sun. You can envision the Kuiper Belt as a larger, colder version of the asteroid belt. However, unlike the asteroid belt's predominantly rocky composition, Kuiper Belt objects are primarily frozen bodies composed of water ice, ammonia, and methane ice. These are remnants of primordial material left over after the formation of the solar system's planets 4.6 billion years ago. This region is home to many notable dwarf planets, such as Pluto, Eris, and Haumea. Pluto is no longer considered a true planet, but as the most famous member of the Kuiper Belt, it reveals the richness and activity of this distant realm. Images transmitted by the New Horizons probe reveal Pluto possesses complex terrain, including towering ice mountains and vast plains of nitrogen ice. This completely overturned our perception of this region as a lifeless wasteland. The Kuiper Belt resembles a necklace encircling the solar system, composed of icy debris. These celestial bodies orbit the Sun in relatively stable, nearly circular paths. Yet, occasionally, gravitational perturbations from giant planets like Neptune alter their trajectories. Some are flung toward the inner solar system to become what we call short-period comets. Their orbital periods typically fall below 200 years, such as the famous Halley's Comet. Though its origin may be more complex, many similar short-period comets originate from the Kuiper Belt. Now let us turn our gaze to even greater distances, where a more mysterious and enigmatic realm exists: the Oort Cloud. The Oort Cloud is a hypothesized giant spherical cloud, enveloping the entire solar system. Its outermost boundary may extend nearly 1 light-year from the Sun. This means the inner edge of the Oort Cloud is nearly 2,000 times farther from the Sun than the Kuiper Belt. Its outer edge nearly touches interstellar space, reaching the very edge of the Sun's gravitational influence. There, the Sun's pull is so faint it nearly matches that of neighboring stars. The Oort cloud is believed to be a direct remnant of the solar system's early formation. Astronomers propose that, during the solar system's infancy, icy planetesimals forming near the giant planets were flung into extremely distant orbits by the powerful gravitational slingshots of Jupiter and Saturn. These exiled icy cores eventually settled to form a vast spherical cloud. The Oort cloud may contain trillions or more of such icy celestial bodies, whose combined mass could equal several Earths. Yet due to their immense spatial distribution, they remain extremely distant from one another. The Oort cloud is the primary source of long-period comets, whose orbital cycles can span thousands or even millions of years. When an Oort cloud comet is nudged toward the inner solar system by some force, it begins a prolonged descent lasting millions of years. So what force stirs these dormant ice cores beyond the reach of light? As discussed in earlier chapters, the gravitational field of the Milky Way plays a pivotal role. As the solar system traverses the Milky Way, particularly during its periodic passages near the galactic plane, or close encounters with other stars and massive molecular clouds, the gravitational pull of these external bodies acts like an invisible giant hand, gently nudging the orbits of objects within the Oort cloud. Such gravitational perturbations can jolt some icy nuclei from their stable orbits, sending them on extremely elongated elliptical paths toward the inner solar system. As these icy nuclei gradually approach the Sun, solar radiation begins to exert its influence. Upon entering the inner solar system, solar heat causes the ice on their surfaces to sublimate directly, transforming from solid to gas. The ejected gas and dust are swept away by the solar wind, forming the cometary coma we observe, and often two beautiful tails. One is a straight ionized gas tail, and a slightly curved dust tail. These comets are not merely celestial spectacles in the night sky. They are messengers from the solar system's ancient past. Their icy cores preserve primordial material from the solar system's formation 4.6 billion years ago. Studying them is like reading a chronicle of the solar system's infancy. Furthermore, one theory suggests that in Earth's early formation, it was precisely these comets from the Kuiper Belt and Oort cloud, acting like cosmic transport ships, that delivered vast quantities of water and other organic molecules to the young Earth, providing the fundamental building blocks that made life possible. In this sense, our oceans on Earth, and even parts of our own bodies, may trace their origins to these distant, ancient, icy visitors. The Kuiper Belt and Oort cloud collectively define the cosmic boundaries of our home. They are not only the source of comets, but also the archives of our solar system's history. Their existence reminds us that the solar system's territory extends far beyond the familiar planets, to encompass a vast domain spanning light years. When we gaze at the night sky and contemplate the profound darkness beyond our sight, knowing that such vast and ancient frozen worlds exist, waiting silently to be awakened by gravity, to embark on their long journey toward the Sun's heart, this realization makes us feel both our own insignificance and inspires profound awe for the grandeur and interconnectedness of the universe. In this grand narrative woven by gravity and orbits, Earth is merely a small stage, yet it plays out the most extraordinary story of life. Tonight, as you prepare to sleep, imagine these distant worlds of ice, quietly guarding the solar system's frontier. Their rhythms span millions of years. Compared to this, our daily troubles seem fleeting. In this serenity brought by the deep cosmos, may you lay down all burdens and drift peacefully into dreams. Once we grow accustomed to Earth's rotation and revolution, and comprehend the solar system's mad dash around the galactic center. A deeper cosmic truth emerges, that our very Milky Way galaxy does not hover motionless in the cosmos, but drifts at a staggering 600 kilometers per second, drifting in an endless grand voyage. Astronomers call this intrinsic motion of the Milky Way its proper motion velocity, sometimes translated as peculiar velocity. This speed is 2.7 times faster than the Sun's orbit around the galactic center, and over 20 times faster than Earth's orbital speed. Imagine this scene. Our Earth, like a speck of dust, clings to a small escort vessel called the solar system. This escort vessel orbits a colossal mothership named the Milky Way galaxy. And this mothership, spanning 100,000 light-years, glides silently through the cosmic darkness at unimaginable speeds. So, in a universe without absolute reference points, how do we measure the Milky Way's velocity? Scientists discovered a brilliant cosmic background reference, the cosmic microwave background radiation. This radiation is residual thermal energy from the Big Bang, uniformly permeating every corner of the universe, as if providing a fundamental background temperature of approximately minus 270.15 degrees Celsius. The Milky Way's proper motion induces minute inhomogeneities in the observed cosmic microwave background radiation. Specifically, in the direction ahead of the Milky Way's motion, the radiation appears slightly warmer due to the Doppler effect, as if compressed. Conversely, radiation behind the motion appears slightly cooler, as if stretched. These minute temperature variations are known as the cosmic microwave background dipole anisotropy. By precisely measuring the pattern and amplitude of these temperature fluctuations, scientists can infer the Milky Way's velocity and trajectory along its proper motion direction. This is akin to driving at high speed on a windless day, where you feel the resistance of oncoming air. Though you see no stationary reference point, your body's sensation of wind confirms your motion. The cosmic microwave background radiation serves as this cosmic wind, enabling us to perceive the Milky Way's grand cosmic voyage. Measurements indicate the Milky Way, carrying all its stars, planets, and nebulae, is hurtling toward the region between Hydra and Centaurus. This velocity vector encompasses not only the galaxy's own motion, but also the combined effects of other galaxies within the local group. Our Milky Way, along with its larger neighbor the Andromeda Galaxy, and dozens of smaller galaxies, bound together by mutual gravitational forces, to form a structure known as the local group. They drift collectively like a vast cosmic raft, adrift in an ocean of gravity. The fundamental force driving this drift originates from a gravitational source of unimaginable power deep within the cosmos. It is called the Great Attractor, a massive gravitational anomaly at the heart of the Laniakea Supercluster. Understanding proper motion liberates us from fixed mental frameworks. No celestial body in the universe remains absolutely stationary. Motion is absolute while stillness is always relative. From minuscule planets to colossal galaxies, all matter is bound within a cosmic web woven by gravity, engaged in an eternal dance and drift. Our Earth, and we who dwell upon it, are inescapably part of this grand motion. Tonight, as you lie in bed, try to sketch this image in your mind. We are aboard Earth, this tiny spacecraft, following the solar system fleet, guided by the immense mothership that is the Milky Way galaxy, traveling at 600 kilometers per second, steadfastly sailing toward an unknown abyss in the cosmos. This realization may bring a touch of insignificance, but more profoundly, it should offer a wondrous sense of release. Our personal worries and conflicts seem utterly trivial in this journey spanning hundreds of millions of light years. In this eternal cosmic drift, perhaps we can more easily let go of our attachments, surrendering ourselves to this profound stillness, and sleep peacefully under the stars' watch. To understand the cosmic microwave background, this mysterious force from the depths of the universe, we must return to that serendipitous yet monumental discovery in the 1960s. At the time, two engineers from Bell Labs, Penzias and Wilson, were calibrating an extremely sensitive horn-shaped antenna. They sought to eliminate all background noise for a communications experiment. Yet they discovered that no matter which direction they pointed the antenna in the sky, an inexplicable, persistent, faint noise signal persisted. This signal uniformly permeated the entire sky, as if the universe itself were humming softly. Initially, they suspected pigeon droppings on the antenna caused the interference. But after thoroughly cleaning it and ruling out all possible technical faults, this mysterious background noise persisted. They did not realize they had touched upon the echoes of the universe's origin. Meanwhile, at nearby Princeton University, a team of physicists led by Dick was theoretically predicting the existence of this radiation as a remnant of the Big Bang. When the two teams made contact, the truth became clear. Penzias and Wilson had accidentally discovered the cosmic microwave background radiation. This discovery earned them the Nobel Prize in Physics and provided humanity with the most fundamental reference framework for observing the cosmos. The cosmic microwave background radiation is the lingering glow, emitted approximately 13.8 billion years ago, when the universe was born as a dense, fiery primordial fireball. It is the afterglow left behind after prolonged cooling, recording the earliest structure of spacetime. As the universe expanded and cooled, this light shifted from its initial high-energy gamma rays to the lower-energy microwave spectrum through redshift. Its temperature is a mere minus 270.15 degrees Celsius, just 2.725 degrees above absolute zero. Such frigid radiation permeates the entire cosmic space and should theoretically exhibit near-perfect uniformity. Yet scientific progress often defies expectations. Over the following decades, rapid advances in detection technology, particularly NASA's COBE satellite and the Wilkinson Microwave Anisotropy Probe, enabled scientists to map the cosmic microwave background radiation across the entire sky with unprecedented precision. They discovered this background radiation is not absolutely uniform, but exhibits minute temperature fluctuations. These ripples measure just 100,000th of a Kelvin in scale, like minute ripples on a tranquil lake. These temperature ripples hold profound scientific significance. They are believed to be imprints of tiny density variations in the early universe. It was precisely these minute density fluctuations, under the influence of gravity, that gradually coalesced over billions of years into the galaxies, stars, and planets we observe today. Amidst all these subtle ripples, scientists have identified the largest and most distinctive pattern, the dipole anisotropy. This appears as a large-scale temperature gradient in the cosmic microwave background radiation map. In one direction of the sky, the radiation temperature is slightly higher, while in the exact opposite direction, the temperature is slightly lower. This pattern cannot be explained by the formation of structures in the early universe. The most plausible explanation is that our Milky Way galaxy is moving relative to this background radiation framework, based on the Doppler effect principle. When we move toward a certain direction, electromagnetic waves from that direction have their wavelengths compressed, frequencies increased, and energy amplified, manifesting as slightly higher temperatures. Conversely, electromagnetic waves from behind us have their wavelengths stretched, frequencies decreased, and energy weakened, manifesting as slightly lower temperatures. By precisely measuring the magnitude and direction of this temperature difference, astronomers not only confirmed the Milky Way's motion, but also calculated its proper motion velocity at a staggering 600 kilometers per second. This velocity points toward the celestial region between the constellations Hydra and Centaurus. So what force is propelling the entire Milky Way at such a tremendous speed? The answer to this question has directed astronomers gaze deeper into the cosmos. They began searching along the direction of the Milky Way's motion, seeking to uncover the immense gravitational source hidden behind countless galaxies. This is an immensely challenging task, because from Earth's perspective, that direction lies precisely behind the Milky Way's obscuring disk. The dense stars and thick interstellar dust within the galactic plane severely obstruct our view of the universe beyond. It's like trying to see a distant lighthouse through a blizzard. However, by employing dust-penetrating observational techniques such as radio, infrared, and X-ray observations, combined with large-scale redshift surveys, astronomers have gradually pieced together a picture of the universe beyond the galactic disk. They discovered an extremely massive, overdense region of matter, located between 150 and 250 million light-years away from us. Its total mass may be equivalent to tens of thousands of Milky Way galaxies. This immense concentration of mass generates powerful gravity, strong enough to influence the motion of vast cosmic regions, including our own. This is the mysterious region known as the Great Gravitational Source. The supermassive gravitational source is not a single supermassive object, but a complex gravitational center, situated at the intersection of the Hydra-Centaurus supercluster. More precisely, it is the gravitational center of our own Laniakea Supercluster. Laniakea means endless heaven in Hawaiian. This supercluster spans approximately 520 million light-years of cosmic space and contains at least 100,000 galaxies. Our Milky Way is merely a tiny node within this cosmic web. The discovery of the Great Attractor fundamentally transformed our understanding of cosmic structure. It reveals that the universe is not uniformly distributed on large scales, but instead exhibits a filamentary structure. Massive galaxy clusters and superclusters form dense nodes and filaments within the cosmic web. Between them lie vast voids. The Great Attractor stands as a crucial gravitational node within our local cosmic structure. Like a colossal cosmic magnet, it draws vast regions, including our own local group, toward its center. Interestingly, due to the overall effect of cosmic expansion, we will never actually collide with the Great Attractor. The expansion of space on larger scales counteracts the approach velocity caused by this local gravitational pull. We are more like drifting in an expanding river. Though we paddle desperately toward a whirlpool, the river itself carries us ever further downstream. Thus our destiny, guided by gravity, is to sail perpetually toward this cosmic abyss yet never truly reach it. As we lie in bed tonight, contemplating the minute temperature ripples in the cosmic microwave background radiation, it bears not only the imprint of the universe's birth, but also serves as the compass guiding us to discover our own grand voyage within the cosmos. It reveals the complete chain of motion, from Earth's rotation to the Milky Way's drift, linking us to 13.8 billion years of cosmic history and mysterious gravitational sources millions of light-years away. On this eternal journey guided by the oldest starlight, all our troubles dissolve into the grand narrative of the universe. May this serenity from the cosmos' deepest depths accompany you into peaceful slumber. When we stand on Earth gazing at the night sky, every bright star we see belongs to our Milky Way family. And the Milky Way, along with dozens of neighboring galaxies like Andromeda and Triangulum, together form the local group community. The local group spans approximately 10 million light-years, yet this is merely the beginning of cosmic structure. The local group, along with other galaxy groups, is embedded within the vast Virgo supercluster. This supercluster encompasses roughly 100 galaxy groups and clusters, spanning 110 million light-years. Yet it wasn't until the 21st century that astronomers truly recognized. Even the Virgo supercluster is merely part of a grander structure. This structure was named the Laniakea Supercluster in 2014. Laniakea means endless heaven or vast sky in Hawaiian. This name perfectly captures the supercluster's immense nature. The Laniakea Supercluster spans approximately 520 million light-years of cosmic space, with a mass equivalent to 100 billion times that of the Sun. It contains at least 100,000 galaxies. These galaxies are not randomly scattered throughout space, but are distributed along a delicate cosmic filament network, forming a complex structure resembling neurons. Scientists mapped the boundaries of Laniakea by observing the proper motions of galaxies to delineate the boundaries of Laniakea. All galaxies flowing toward the same gravitational center are considered part of the same supercluster. Within Laniakea, galaxies flow along cosmic filaments toward a single gravitational abyss, like countless streams converging into a mighty river. This grand gravitational center is the Great Attractor, located at the core of the Laniakea Supercluster, a gravitationally polarized point of extreme mass concentration. Despite the Milky Way's distance of approximately 150 to 250 million light-years from the Great Attractor, we remain unable to resist its gravitational pull, moving toward it at hundreds of kilometers per second. Laniakea's shape resembles a vast cosmic leaf, featuring delicate filaments and an expansive surface. Within this cosmic leaf, several major components can be identified, including the familiar Virgo supercluster, the Hydra-Centaurus supercluster, and the Peacock-Indian supercluster. These superclusters are interconnected by filaments of galaxies, forming the skeletal framework of Laniakea. Between these skeletal structures lie vast cosmic voids. These voids are nearly empty, spanning hundreds of millions of light-years in diameter. The Laniakea supercluster itself is not the edge of the universe. It belongs to an even larger structure, the Pisces-Cetus supercluster complex. This complex spans billions of light-years and ranks among the largest known structures in the cosmos. At such scales, the universe reveals a cellular, web-like architecture. Clusters and superclusters form the nodes and filaments of this network, while voids constitute its cavities. This structure originated from quantum fluctuations in the early universe. Through 13.8 billion years of gravitational evolution, it ultimately formed the large-scale cosmic structure we observe today. Understanding the concept of Laniakea invites us to redefine home. Our home is not merely Earth or the solar system, nor even the Milky Way alone. It is this vast cosmic structure encompassing 100,000 galaxies. Within this boundless expanse, the Milky Way is but one in 100,000, and the solar system is but a speck of dust. While Earth is not even dust, this realization makes us feel small, yet marvels at the universe's grand design. Within this 520 million light-year wide home, each galaxy under gravity's command plays its part in the cosmic symphony. Our motion, our position, our destiny are all intricately linked to this larger structure. The discovery of Laniakea has transformed astronomers' view of the cosmos. It reveals that the universe is not a uniform collection of galaxies, but a complex, hierarchical network. Within this web, gravity reigns supreme, shaping every structure from planets to superclusters. As we drift off to sleep at night, imagine lying within the embrace of this vast cosmic home, gently cradled by the gravitational pull of 100,000 galaxies, under the protection of this infinite paradise. Our sleep becomes part of the cosmos itself, synchronized with the rhythm of stellar streams, resonating with the universe's breath. Within this profound sense of belonging, all anxieties dissolve into the starry seas, leaving only tranquility and peace filling our hearts. In the grand theater of the cosmos, gravity is the unseen director, silently orchestrating the trajectories of all celestial bodies, from an apple falling to the moon orbiting Earth, from Earth revolving around the sun to the solar system racing around the galactic center, to the Milky Way itself tumbling toward a supermassive black hole. All these motions are governed by a single fundamental force. This is universal gravitation. Newton first described gravity mathematically in the 17th century. He revealed that every object with mass in the universe attracts every other object with mass. The strength of this gravitational force is directly proportional to the product of their masses, and inversely proportional to the square of the distance between them. This law successfully explained the motion of objects on Earth and the orbital patterns of planets around the Sun. But when Einstein introduced general relativity in the early 20th century, our understanding of gravity underwent a revolutionary shift. In Einstein's theory, gravity is no longer a traditional pull, but a geometric effect caused by mass warping spacetime. Imagine the universe's spacetime as a vast elastic membrane. When a massive object rests upon this membrane, causes the membrane to sag. Other objects then move along this curved surface. This warped geometry is the gravity we perceive. The Earth orbits the Sun, not because the Sun attracts it, but because the Sun's mass warps the surrounding spacetime. The Earth simply follows the most natural geodesic path through this curved spacetime. This is akin to a ball rolling along the rim of a funnel. It spirals along the curved walls of the funnel, without requiring any direct pulling force. When we expand our view to the cosmic scale, this effect of spacetime curvature becomes even more pronounced. The distribution of all matter in the universe, including visible galaxies, stars, and planets, along with invisible dark matter, weaves a vast gravitational web. Its nodes are superclusters, its fibers are galaxy filaments, and its mesh is the vast cosmic voids. The Laniakea Supercluster is a local structure within this web. Our Milky Way galaxy lies along one of its filaments. Dark matter plays a pivotal role in this gravitational web. Though we cannot directly observe dark matter, its gravitational effects on visible matter reveal that its total mass exceeds that of ordinary matter by more than 5 times. Dark matter forms the skeletal framework of cosmic structures, providing the gravitational foundation for ordinary matter to aggregate. Without dark matter's gravitational influence, galaxies and galaxy clusters could never have formed within the age of the universe. The gravitational web not only shapes the static structure of the cosmos, but also drives its dynamic evolution. In the early universe, matter distribution was nearly uniform, with only minute density fluctuations. Yet, under gravity's influence, these tiny ripples gradually amplified. Denser regions attracted more matter through gravity, while regions of lower density gradually shed matter. After 13.8 billion years of evolution, the cosmic web structure we observe today has emerged. Throughout this evolutionary process, gravity acts like a patient sculptor, using an exceedingly slow yet unwavering technique to carve the primordial chaos into intricate structures. Galaxies flow along gravitational filaments toward nodes, much like water droplets sliding toward the center of a spider web. This flow is not chaotic or disordered, but follows the gradient direction of the gravitational field. Our Milky Way's motion toward the Great Attractor is a natural descent along the gravitational filament of the Laniakea Supercluster. toward this region's lowest gravitational point. Interestingly, this sculpting action of gravity continues to this day. By precisely measuring the velocities of galaxies, astronomers can reconstruct the distribution of the universe's gravitational field. This is akin to inferring the undulating topography beneath water by observing the movement of leaves on its surface. This technique, known as cosmographic velocity field reconstruction, enables us to glimpse the invisible landscape of gravity. Within this gravitational terrain, the Great Attractor resembles a profound gravitational basin, drawing in all matter within millions of light-years. The Laniakea Supercluster serves as the basin's watershed. Any matter within this sphere will eventually flow toward this gravitational center. However, due to the universe's accelerating expansion, this matter may never actually reach the gravitational center. They resemble ants crawling on an expanding balloon, though striving to move forward. The balloon's expanding surface perpetually pushes their destination farther away. This is the cosmic scale myth of Sisyphus. We perpetually advance toward our destination, yet may never arrive. The concept of the gravitational web reveals that the universe is an interconnected whole. Every part is linked to others through gravity. The Milky Way's motion is influenced not only by neighboring galaxies, but also by massive distributions of mass billions of light-years away. This non-local interconnectedness reveals the universe's astonishing unity. As we lie in bed contemplating these ideas, we might sense a profound connection between ourselves and the entire cosmos. Every atom within our bodies participates in this cosmic dance governed by gravity. Our breath, our heartbeat, share the same physical laws as the motion of galaxies. Within this invisible web of gravity, nothing truly exists in isolation. All things are connected. All beings are one. This realization may bring a profound sense of peace, allowing us to find, within the embrace of the cosmos, our most primal sense of tranquility. With each breath's rhythm, imagine yourself floating upon this gravitational web, gently supported by the universe's most fundamental force. All tension and anxiety dissolve into the flow of the cosmos, leaving only tranquility and peace filling your heart. Within this cosmic-level sense of security, sleep becomes the most natural gift, allowing us to merge with the universe's rhythm. Under the stars' watchful care, we enter the deepest repose, tracing back through the long cosmic voyage. From Earth's rotation to the migration of the Milky Way, we finally return to this very spacecraft that carries everything. In the vast universe, Earth's most extraordinary feature lies in being the only known planet to have nurtured life. This uniqueness rests upon countless precise conditions working in perfect harmony, forming a miracle on a cosmic scale. First, Earth occupies the golden position within the solar system's habitable zone, a region neither too close nor too far from the sun, that precisely allows liquid water to persist stably on the planet's surface. Water serves as the fundamental medium for life's chemical reactions, and its liquid form is crucial for the formation and interaction of organic molecules. If Earth's orbit were just 5% closer to the sun, it would trigger an uncontrollable greenhouse effect. Surface temperatures would soar to hundreds of degrees Celsius, transforming it into a furnace world like modern Venus. If the orbit were 20% farther from the sun, Earth would plunge into a global ice age. Similar to Mars, water would exist only as permafrost, losing the life-incubating function of liquid oceans. Earth's size and mass are equally just right. Its moderate mass generates sufficient gravity to retain an atmosphere dominated by nitrogen and oxygen. This atmosphere not only provides breathable air for life, but also acts like a warm blanket regulating global temperatures. and preventing extreme temperature fluctuations like those on Mercury. Simultaneously, the atmosphere forms the first line of defense, causing most meteorites to burn up before reaching the surface, and shielding life from the threat of frequent impacts. Earth's active tectonic system perpetuates material cycles through plate movement. This cycle brings minerals from the depths to the surface, while burying atmospheric carbon underground, effectively regulating atmospheric composition and greenhouse effect intensity. Without this geological thermostat mechanism, Earth might have long since become scorching like Venus, or cold and lifeless like Mars. The Moon's presence provided crucial assistance to Earth's life evolution. This unusually large satellite, through gravitational forces, stabilized the tilt of Earth's rotational axis. It has maintained the Earth's axial tilt at approximately 23 degrees over long periods. This stability ensured the regular alternation of seasons, providing a stable evolutionary environment for complex life. Without the Moon's protection, Earth's rotational axis might have undergone violent oscillations on a scale of millions of years, causing climate to oscillate between extremes, and preventing the emergence and development of advanced life. Earth's magnetic field offers equally indispensable protection. The powerful magnetic field generated by the flowing core acts like a protective shield, deflecting harmful solar winds and cosmic rays. Without this magnetosphere, Earth's atmosphere would gradually be stripped away by solar winds, exposing the surface to lethal radiation, making life difficult to sustain or even impossible to originate. Earth's position in the solar system also benefits from Jupiter's protection. This gas giant, through its immense gravitational pull, clears the inner solar system of numerous hazardous objects, deflecting many asteroids and comets that could have collided with Earth, significantly reducing the probability of giant celestial impacts, and providing a secure environment for life's long-term evolution. Earth's uniqueness is further reflected in its chemical composition. It possesses abundant volatile elements, including water and nitrogen essential for oceans and atmosphere, along with carbon-forming life's structural backbone. These elements were delivered to the young Earth via meteorites and comets during the solar system's early formation, laying the material foundation for life's emergence. The biosphere itself profoundly reshapes Earth's environment. Cyanobacteria released oxygen through photosynthesis, radically altering the primordial atmosphere's composition and enabling the birth of oxygen-dependent life. Plants accelerate rock weathering through their root systems and influence the global carbon cycle rate. This coevolution between life and environment keeps Earth in a state suitable for sustaining life. When we look across the Milky Way galaxy, it is estimated that trillions of star systems exist, many of which possess their own planets. Yet, the probability of all conditions for life existing simultaneously is so low it invites deep reflection. Suitable star-type stable orbital path, appropriate planetary size and composition satellite similar to the Moon, protection by a strong magnetic field guardian giant planets. The simultaneous occurrence of these conditions makes Earth exceptionally precious in the cosmos. Within the known solar system, Mars, though situated at the edge of the habitable zone, lost its magnetic field due to insufficient mass, and had its atmosphere nearly stripped away by solar wind. Venus, meanwhile, became a scorching inferno due to runaway greenhouse effects. Other moons like Enceladus and Europa possess subsurface oceans yet lack Earth's environmental diversity. When we trace Earth's evolutionary history, from primordial single-celled organisms to complex ecosystems, it endured at least 5 mass extinction events. Yet life consistently flourished anew. This resilience demonstrates life's tenacity. while highlighting Earth's uniquely accommodating environment. In the dark forest of the cosmos, Earth stands like an isolated lighthouse, radiating the light of life. Each of its characteristics is precisely calibrated, like the most intricate clockwork mechanism. A deviation in any single gear would cause the entire system to fail. Understanding Earth's rarity compels us to re-examine our role within our home. As passengers aboard this cosmic vessel, conscious of our existence, we both revel in the gifts of this unique environment and bear the responsibility to safeguard this precious legacy. Tonight, as you prepare for sleep, feel the warm embrace of this cosmic vessel. Over 4 billion years, it has meticulously crafted this sanctuary for life. Amidst this cosmic rarity, all troubles seem insignificant. May this realization bring you profound gratitude and peace. Within life's oasis, a safe harbor, let sleep be like returning to life's original home. Under the stars' watch, enter the most tranquil dreams, following gravity's trail, from Earth's rotation to the solar system's orbit, then from the Milky Way's spin to the Laniakea Supercluster's flow. We finally reach the great gravitational anchors, this powerful gravitational center. Yet scientific exploration never halts at a single answer. Astronomers discovered that the Great Attractor itself is not stationary. It is merely a transit point within the larger scale flow of the universe. The entire Laniakea Supercluster, including the Great Attractor and our own Milky Way, is moving toward another, more distant gravitational abyss. This new destination is the Shapley Supercluster, one of the largest known concentrations of mass in the cosmos, situated approximately 600 million light-years from our home galaxy. The discovery history of the Shapley Supercluster traces back to the 1930s. At that time, astronomer Harlow Shapley, while observing the distribution of galaxies beyond our Milky Way, noticed an unusually dense cluster of galaxies in the direction of Scorpius and Centaurus. With advances in observational technology, particularly the launch of large-scale sky survey projects, scientists gradually recognized the true scale of this region. The Shapley Supercluster contains over 8,000 bright galaxies and tens of thousands of fainter galaxies. Its total mass may be equivalent to 10,000 Milky Ways. This staggering mass generates immense gravitational forces, capable of influencing the flow of cosmic matter across hundreds of millions of light-years. To comprehend cosmic motion at this scale, we must introduce the concept of the cosmic flow field. Imagine vast open plains, where countless streams converge into brooks. Brooks merge into rivers, and rivers ultimately flow to the ocean. Matter flows in the universe follow a similar pattern. Galaxies, like droplets in a stream, flow down gradients of gravitational potential energy. This flow forms the grand circulation of the cosmos. By measuring the positions and velocities of hundreds of thousands of galaxies, astronomers have mapped the flow field of our local universe. On this map, we can clearly see how matter flows out from cosmic voids, along filaments of galaxies toward centers of mass, ultimately forming a material cycle spanning hundreds of millions of light-years. Within this magnificent circulation, our Laniakea Supercluster resembles a vast river flowing toward the Shapley Supercluster. The Milky Way is but a single droplet within this river. This hierarchical motion compels us to reconsider gravity's scope of influence. At the largest cosmic scales, gravity reveals its true power. It not only binds planetary systems and galaxies, but also drives supercluster-scale material flows, shaping the universe's overall structure. Interestingly, these large-scale flows form a delicate equilibrium with the universe's accelerated expansion. Dark energy, the mysterious force driving cosmic acceleration, dominates cosmic evolution at the largest scales. It causes distant galaxy clusters to drift apart, while on relatively smaller scales of hundreds of millions of light-years, gravity remains dominant, compelling matter to coalesce toward mass centers. This tug-of-war between gravity and dark energy determines the ultimate fate of cosmic structures. Our own trajectory thus becomes complex and nuanced. On one hand, we are pulled by gravitational forces within the Laniakea Supercluster toward the great gravitational source. On the other hand, the entire Laniakea Supercluster follows cosmic flows, moving toward the Shapley Supercluster. Simultaneously, the expansion of the universe pushes us away from all these destinations. This multi-layered motion reveals the astonishing complexity of cosmic dynamics. Tracing the origins of these cosmic flows reveals they ultimately connect to the dipole anisotropy of the cosmic microwave background radiation. This earliest detected cosmic asymmetry not only confirms the Milky Way's proper motion, but also serves as the initial driving force for matter flows throughout the local universe. Like a hydrological map on cosmic scale, guiding matter on its billion light-year journey to find its gravitational destination. In this endless voyage, each gravitational center is merely a temporary stop. Beyond the Shapley Supercluster lie even greater mass concentrations and more monumental cosmic flows awaiting us. Recent observations suggest that beyond the Shapley Supercluster may exist a colossal structure dubbed the Southern Wall. This structure extends over 1.4 billion light-years, making it one of the largest known cosmic features. Its gravitational influence shapes the distribution of matter on an even grander scale, driving numerous superclusters, including the Shapley Supercluster, to move toward it. Such discoveries compel us to ponder whether the universe harbors an ultimate gravitational center, or if the entire cosmos resembles an infinite set of Russian nesting dolls, where each layer points to a larger one above. Modern cosmology answers no. Beyond scales of roughly 3 billion light-years, cosmic expansion begins to completely overwhelm gravitational aggregation effects, preventing matter from forming larger coherent structures. Thus, the cosmic flow we observe actually possesses a physical limiting scale. Above this scale, the universe exhibits an isotropic, homogeneous state where all motion merges into the overarching pattern of cosmic expansion. Understanding these grand cosmic flows grants us a new perspective on our own position. We do not merely inhabit a planet, within a star system, within a galaxy, but participate in a cosmic migration spanning hundreds of millions of light-years. This migration has no beginning and no end, only eternal flow and transformation. From this perspective, personal worries and troubles dissolve into the grand narrative of the universe. Tonight, as you prepare for sleep, imagine yourself drifting with the Milky Way, drifting in this boundless cosmic current. Our trajectory traverses time and space, connecting the universe's past and future. In this eternal voyage, each sleep is a brief docking, allowing us to rest in the embrace of stellar currents, gathering strength for tomorrow's journey. May this awareness of the universe's infinite journey bring you profound peace. Guided by the stars, enter dreamless sleep, this Earth spacecraft that carries us. Though it has undergone billions of years of evolution and refinement, its ecosystem reveals astonishing fragility. As the most intelligent passenger aboard this vessel, humanity is altering the spacecraft's environment in unprecedented ways. Since the Industrial Revolution, atmospheric carbon dioxide concentrations have surged from approximately 280 ppm to over 420 ppm. This rate of change far exceeds natural fluctuations in Earth's history. The increase in greenhouse gases like carbon dioxide is like wrapping the spacecraft in an excessively thick insulation layer, causing global average temperatures to rise continuously. Polar ice caps are melting at an accelerated pace. Rising sea levels threaten coastal ecosystems, and extreme weather events grow more frequent and intense. Our excessive reliance on fossil fuels not only intensifies the greenhouse effect, but also releases vast quantities of pollutants into the atmosphere. Fine particulate matter like PM 2.5 penetrates deep into human lungs, causing millions of premature deaths annually. Acid rain damages forests and aquatic systems, altering soil chemistry and impacting crop growth. Earth's biodiversity faces the sixth mass extinction. Species are vanishing at rates over 100 times faster than natural background levels. Tropical rainforests disappear at a rate of 30 football fields per minute. These forests are not only home to countless species, but also vital carbon sinks and climate regulators. Coral reefs bleach en masse due to ocean warming and acidification, threatening the survival of 1/4 of marine life. Freshwater systems endure immense pressure. Most major global rivers experience reduced flow. Groundwater overextraction causes persistent water level decline. Water pollution makes clean drinking water increasingly scarce. Chemical pollutants, plastic microplastics, and pharmaceutical residues enter the water cycle through various pathways, posing long-term threats to ecosystems and human health. Land degradation worsens daily. Overcultivation leads to soil organic matter depletion. Desertification threatens 1/3 of the world's land area. Each year, 12 million hectares of land lose productivity due to drought and desertification, equivalent to losing 23 hectares of fertile soil every minute. Plastic pollution now permeates every corner of the planet, from the deepest ocean trenches to the highest mountain peaks. Microplastics have even entered the human bloodstream. These non-biodegradable materials accumulate persistently in the environment, concentrating through the food chain. Their long-term impacts remain difficult to fully assess. Human activities have also disrupted natural nitrogen and phosphorus cycles. Excessive fertilizer use causes water eutrophication, forming vast dead zones, where oxygen depletion from algal blooms prevents most marine life from surviving. Our insatiable demand for energy drives reckless extraction of natural resources. Unsustainable mining not only depletes Earth's finite reserves, but also inflicts severe ecological damage, generating vast quantities of waste that pollute the environment. Alarmingly, these challenges are interconnected, forming a complex web of crises. Climate warming exacerbates water scarcity. Biodiversity loss weakens ecosystem resilience. Pollution issues intertwine with public health crises. Together, these challenges test the carrying capacity limits of Spaceship Earth. Earth's self-regulating systems show signs of fatigue. Melting Arctic permafrost releases more greenhouse gases. The Amazon rainforest approaches the tipping point from carbon sink to carbon source. Ocean circulation systems may undergo abrupt changes. Once these tipping points are triggered, they could set off irreversible chain reactions. Yet, in the face of these daunting challenges, humankind shows signs of awakening. Renewable energy costs continue to decline. Protected areas steadily expand. Circular economy principles gain widespread adoption. Global environmental governance mechanisms gradually improve. We are beginning to understand the operating principles of Spaceship Earth, recognizing the intricate connections between its systems. Atmosphere, oceans, land, and biosphere form a complex life-supporting system. Damage to any part affects the whole. As the intelligent life aboard this vessel, We are both the most destructive force and the most likely savior. Our technological capabilities and global influence bestow upon us a unique responsibility to meet the needs of the present generation without compromising the development rights of future generations. Tonight, as you lie in bed, contemplating our relationship with this cosmic vessel, you may sense the weight of responsibility and mission upon your shoulders. The Earth spacecraft's journey continues, and its future state depends largely on the choices we make today. In this clear-eyed awareness, let us seek inner peace. Within the commitment to safeguard our home, find the strength for restful sleep. Standing on the deck of this spaceship called Earth, we bear a unique dual mission: to gaze upward at the stars and explore the profound mysteries of the cosmos, and to keep our feet firmly planted, safeguarding the fragile home beneath our feet. These two seemingly opposing directions, in fact, form the complete trajectory of human civilization's development. Gazing at the stars is our innate instinct. Since ancient times, humanity has observed celestial phenomena to find our place in the cosmos. Modern astronomy reveals Earth is but a speck of dust in the universe. This realization does not diminish us, but illuminates our unique value. In the known cosmos, we are the only beings capable of pondering these questions. Space exploration has granted us a wholly new perspective. From the Apollo program's photograph of Earth rising, to the Voyager spacecraft's distant view of the pale blue dot, these images have forever altered how we perceive ourselves. We now recognize Earth as a complete ecosystem, without borders, but with a shared destiny. This perspective is crucial for addressing global challenges. Exploring the cosmos also drives tangible technological advancements. Satellite communications enable instant global connectivity. Weather satellites help predict natural disasters. Earth observation satellites monitor environmental shifts. Global positioning systems revolutionized navigation. Medical imaging technologies originated from space research. These innovations have improved the lives of billions. Simultaneously, we've developed new technologies to protect our planet. Renewable energy sources are gradually replacing fossil fuels. Energy-efficient materials reduce consumption. Environmental monitoring networks provide early warnings of ecological crises. Clean production technologies reduce pollution emissions. These are all terrestrial benefits brought by the space age. Yet technological progress alone is far from sufficient. We must establish a new Earth ethic, recognizing the intrinsic value of all life forms, understanding the indispensability of ecosystem services, building a new relationship of harmony with nature. This ethic should become a shared consensus for all humanity. Grounded action means embracing the responsibility to safeguard our planet. We must transform our development model from a linear economy to a circular economy, to reduce resource consumption and waste generation, protect biodiversity and ecosystems, and restore damaged natural environments. All this requires tangible actions from every individual. Education plays a pivotal role. We must cultivate global citizenship awareness, so the next generation understands how ecosystems function, acquires the knowledge and skills for sustainable development, and develops a lifestyle that respects nature. These competencies will form the foundation of future societies. Policymaking must be grounded in scientific evidence. The international community must strengthen cooperation to jointly address global challenges like climate change and establish fair and effective governance mechanisms, ensuring both developed and developing nations share the responsibility for emissions reduction. To achieve true climate justice, business must transform its operational philosophy, by integrating environmental protection into core strategies, developing green products and services, implementing full life cycle environmental management, and achieving economic and ecological win-wins through innovation. These shifts are occurring globally. As individuals, we can also contribute. Choose sustainable lifestyles, reduce energy and resource consumption, support eco-friendly products and enterprises, participate in community environmental protection activities, drive systemic change through daily choices. Science and humanities require deep integration. Technological innovation must be guided by values. We must develop clean energy, while reflecting on consumerism's cultural impact. We must explore extraterrestrial colonization, while improving living conditions on Earth. These two directions should mutually reinforce each other. In the cultural sphere, we need new narratives. Stories of humanity living in harmony with nature. Artworks reflecting ecological consciousness. Modern rituals honoring traditions that respect life. These cultural practices can reshape our relationship with Earth. Toward the cosmos, we maintain humble curiosity. Toward Earth, we bear profound responsibility. These attitudes, seemingly contradictory, are fundamentally unified. It is precisely our understanding of the universe's vastness. Let us cherish Earth's uniqueness all the more. It is precisely our awareness of Earth's fragility that inspires us to seek answers among the stars. In this challenging era, we must simultaneously embrace two perspectives, viewing Earth's problems through a cosmic lens, and guiding cosmic exploration with earthly wisdom. Let macro-level thinking illuminate micro-level actions, and let local practices contribute to holistic solutions. Tonight, as you gaze upon the stars, remember this dual responsibility. We are the thinking eyes of the universe. Through us, the cosmos comes to know itself. We are also Earth's guardians. Through our choices, Earth's future is determined. In balancing these dual perspectives, perhaps we find inner peace. In bearing this responsibility, perhaps we attain true tranquility. Let this cosmic scale contemplation accompany you into deep slumber. Under the shared guardianship of stars and Earth, we embrace a tomorrow full of hope. Recognizing Earth's preciousness and fragility is only the first step. What truly matters is transforming this awareness into tangible action. Embarking on the collective journey to safeguard Spaceship Earth demands profound transformation across all levels. Energy transition lies at the heart of this transformation. We must accelerate the shift from fossil fuels to renewable energy. Solar and wind power costs have plummeted, making them the most economical choices in many regions. Geothermal and ocean energy provide stable baseload power. Hydrogen technology offers solutions for hard-to-electrify sectors. Smart grids enable efficient energy distribution and management. Together, these technologies build a sustainable energy future. Transportation systems demand comprehensive innovation. Electric vehicles are progressively replacing gasoline-powered cars. Public transit networks are expanding and improving. Bicycle and pedestrian-friendly urban design enhances resident health. Remote work reduces unnecessary commuting emissions. Efficient logistics systems optimize cargo transport routes. These changes make our mobility more environmentally friendly. Agricultural production must embrace sustainability. Ecological farming preserves soil health and biodiversity. Precision agriculture reduces water and fertilizer usage. Plant-based proteins partially replace meat consumption. Food supply chains minimize waste and spoilage. Urban agriculture utilizes limited space for food production. These practices ensure food security while protecting ecosystems. Industrial production must implement circular economy principles. Product design considers entire life cycles. Material selection prioritizes recyclable components. Manufacturing processes minimize waste generation. Comprehensive recycling systems are established. Product lifespans are extended through repair and upgrades. This model transforms waste into resources. Urban development should follow ecological principles. Green buildings reduce energy consumption. Parks and green spaces improve urban microclimates. Rainwater harvesting systems alleviate water supply pressures. Urban forests provide habitats and carbon sinks. Ecological corridors connect isolated natural areas. Such cities serve as both human habitats and ecological nodes. Technological innovation provides new tools for sustainable development. Artificial intelligence optimizes energy efficiency. Internet of Things monitors environmental changes. New materials enhance product durability. Biotechnology addresses environmental pollution. Blockchain tracks supply chain sustainability. These technologies accelerate the green transition. Education and public awareness are crucial. School curricula incorporate sustainable development content. Media raise public awareness of environmental issues. Community activities promote eco-friendly behaviors. Artistic creation sparks ecological consciousness. Citizen science projects engage the public in research. These efforts cultivate responsible global citizens. Dialogue between science and policy should be strengthened. Scientists provide the latest research findings. Policymakers develop evidence-based policies. Businesses applying scientific innovation. Public understanding of scientific consensus. Such interactions foster informed decision-making. Cultural transformation is equally vital. Redefining the meaning of progress. Valuing quality of life over material consumption. Restoring connection with nature. Cultivating simplicity in living. Celebrating traditions of ecological wisdom. These values underpin sustainable societies. Facing challenges, we must maintain hope. Every energy transition creates new opportunities. Every ecological restoration builds resilience. Every technological innovation opens possibilities. Every policy advancement propels change. Every personal choice makes an impact. These positive shifts are unfolding globally. As crew members aboard Spaceship Earth, we witness its beauty and bear the responsibility to protect it. The journey from awareness to action has begun. Each of us is a co-author of this story. Every action shapes the future's form. Tonight, as you prepare for sleep, feel your profound connection to Earth. Each eco-conscious choice you make is an expression of cherishing the spaceship. In this positive commitment, you may find inner peace, knowing we are co-creating a more sustainable future. Let this hope accompany you to sleep, under the witness of the stars. To embrace tomorrow's actions and change, let us revisit this wondrous cosmic journey. Beginning with Earth's rotation at 0.046 kilometers per second. Guided by gravity, we continually expanded our horizons, witnessing Earth orbit the Sun at 29.79 kilometers per second. Discovering the solar system traversing the Milky Way at 220 kilometers per second. Ultimately realizing the Milky Way itself plummets toward the Great Attractor at 600 kilometers per second. This cosmic voyage, spanning 4.6 billion years, has shaped Earth's unique environment, nurtured diverse life forms, and allowed us humans to open our eyes in this universe, beginning to contemplate our own existence. Whenever we gaze upon the starry sky, we see not merely distant points of light, but a mirror reflecting Earth's destiny. Those twinkling stars remind us, Earth's place in the cosmos is both insignificant and extraordinary. It is a speck of dust, yet a speck that carries the entire story of life. On this spaceship Earth, We are both passengers and crew. We enjoy the blessings of the journey, while bearing the responsibility to safeguard our course. We learn to decipher the stars' codes, understand the language of gravity, and begin to appreciate the rhythms of cosmic motion. Now let us bring this cosmic perspective into our daily lives. As you lie in bed at night preparing to sleep, imagine yourself cradled within the embrace of Earth, this cosmic vessel, participating in its multi-layered cosmic dance. This awareness makes us feel both our own insignificance and the grandeur of being connected to all things. Earth's rotation brings you the cycle of day and night. The moon's gravity regulates your life rhythms. The sun's radiation provides your energy source. The Milky Way's gravitational field guides your cosmic course. All these forces working together create an environment suitable for life and create nights perfect for restful sleep. In this cosmic cradle woven by gravity and motion, you can release all worries and anxieties. Let your spirit slowly calm with Earth's rotation. Let your thoughts gently unfold with the drift of galaxies. In this boundless cosmos, your very existence is a miracle, and your peaceful sleep is part of that miracle. May you remember, each breath connects you to Earth's atmosphere. Each heartbeat resonates with cosmic rhythms. Each sleep is a trust in life's miracle. Each awakening is gratitude for the universe's gift. In this eternal cradle of stars and seas, may you find deepest peace. Lay down all burdens. Surrender yourself wholly to the embrace of the cosmos, guided by gravity's gentle pull, guarded by starlight's tender watch. Enter sweet and tranquil dreams. Good night, guardian of Earth. May you find deepest rest and peace under the gaze of the stars. Awaken refreshed to embrace tomorrow's journey. In this ceaseless cosmic voyage, let us journey onward together.